Welcome to Automated Flight, where I will be discussing the assignment 2, part E of week 7. We have the Laplace transform of x equal to 5 over s times s squared plus 2s plus 4. And we want to get the inverse Laplace transform. What we will start with is first looking at the denominator and identifying what kind of factors we have. Here we have s, which is a linear factor, and it's repeated only once. And here we have a quadratic factor with complex roots, which means that we won't be separating it out in something like s minus s1 times s minus s2, like we would do with with a quadratic factor with non-complex roots. So we won't do that. Instead, we will write it according to the book. Well, so the linear factor, the linear partial fraction is a over s, and the other is b s plus c over s squared plus 2s plus 4. Now, to calculate a, b, and c, we simply multiply these two partial fractions so that they have a common denominator, and of course then the numerator has to become equal to 5, and what we find is a is 5 over 4, b is minus 5 over 4, and c is minus 5 over 2, which means I can rewrite this part as 5 over 4 times 1 over s minus 5 over 4, and I'll just separate out this factor minus 5 over 4 so that I get s plus 2 over s squared plus 2s plus 4. Now, this part I can take the Laplace transform because it is in the table, and this part I can't. So what I'll do is I'll be using the method of completing the square. Completing the square, and that simply means that I will write s plus 2s plus 4 as something like s plus a squared plus b squared. If I write this out, I get s squared plus 2as plus a squared plus b squared, and I want you to focus on this part. I have 2 times a times s. Here I have 2 times s, so we know that a is equal to 1. So I can write this as s plus 1 squared plus some other number. I'm going to do this in my head, so I get, if I multiply these two, if I take the square, I get s squared plus 2s plus 1. So I'm left with 3, which means that b is the square root of 3. And I can write this as s plus 1 squared plus the square root of 3 squared. Now, why would I want to do this? And let's see, yes, you can see the edge of the board. Why would I want to do this? Well, in the Laplace table, I have, if I have I write e to the power of minus at sine of bt. If we take the Laplace transform, we get b over s plus a squared plus b squared, and e to the power of minus at cosine of bt becomes s plus a over s plus a squared plus b squared. So if I can get this part written in terms like these, I can take the inverse Laplace transform. So if I take a and b to be the values that we calculated, I'm looking for s plus 1 over s plus 1 squared plus square root of 3 squared, and I'm looking for square root of 3 over s plus 1 squared plus square root of 3 squared. But I don't have that here yet. I have s plus 2 over this thing. But we can write that as s plus 2 over s plus 1 squared plus the square root of 3 squared. And if you write 3 here, I don't mind, as long as you know that we're looking for this form where we have the square root of 3. Now I have to separate this out. And what I'm going to do is I'm going to focus on this s part here. So I have one s, and I want to have s plus 1, but I have s plus 2. So I will rewrite this as s plus 1 plus 1 and separate out the two, separate this into two fractions. And then we are almost there, because now this part is in the correct form, but this one isn't. But I'm just simply going to multiply it with square root of 3 over square root of 3. And what I get is 1 over square root of 3 times the square root of 3 here. And what I end up with is something here, which I can find in the Laplace table. And I've got something here which I can find in the Laplace table as well, which means that x of s now is minus 5 over 4 times 1 over s minus 5 over 4 times s plus 1 over s plus 1 squared plus the square root of 3 squared plus 1 over the square root of 3, that was this one, plus the square root of 3 s plus 1 square root of 3 squared. So now I've rewritten x of s in terms of three parts that are in my Laplace table. So 1 over s just becomes 1. So x of t is 5 over 4 minus 5 over 4, 5 over 5, 5 over 4 times, well, the inverse Laplace transform of this one, but we know already which one that is. That is e to the power of minus t cosine square root of 3 times t. And this one becomes 1 over, oh, we don't need that one here yet, 1 over the square root of 3 e to the power of minus t sine of square root of 3 times t. And the parenthesis for that factor. Now, I don't like having square roots in the denominator, so what we can do is write 1 over the square root of 3 as square root of 3 over 3. But of course, this answer is just as correct. So the steps for this assignment is 1, perform the partial fraction expansion and recognize that this is something which we will need to rewrite using completing the squares, which is always the case if we get a quadratic factor with complex roots. Identify a and b for this form here. And then identify which parts we're interested in. And then rewrite whatever you have left in terms of those two parts. And then you can use the Laplace table to find the inverse of the Laplace transform of x. And we have x of t.